of Education, Director of Education at Branched Oak Observatory, which is a really nice facility that's just north of Lincoln. All right, let's go ahead and get started, everyone. I'm going to share my screen here. The program that we're about to see is a shortened version of my regular Beyond the Shadow program. So with that in mind, since I've cut this down from an hour to a half hour, we really need to get rolling. So I'd like to welcome everyone to the program. You'll see my email address is info@branchedoakobservatory.com. If you want to, you can snap a picture of that. If there's any content that you'd like some elaboration on, a little more explanation, if you need to follow up in any way, you can send me a message right to that particular email. Now, before we get started, we have to look at safety first here. We will be dealing with, of course, observing the sun during an eclipse, but we'll also be giving you some information on observing the sun really anytime. And this is always an important thing. I'm just going to go ahead and read this out loud. Viewing the unobscured or partially obscured sun without proper protection, even for a short amount of time, can cause permanent eye damage. Be sure to take proper precautions during a solar eclipse or during any solar activities. I will mention now, for those of you that might have to leave a little bit early, I do have solar eclipse glasses available. If you need solar eclipse glasses for your class, whether you need 20 or 100, send me an email and I will get those in the mail to you. I also have a really nice poster here. We'll be talking about this particular graphic. Those are available as well. So you can just send me an email and let me know if you need those. At first glance, the universe may appear not only vast, but also unchanging. But nothing more could be further from the truth. From the very moment of its birth, it's been growing and changing, expanding, evolving, energies cooling into gases, these gases condensing into stars and vast galaxies. And within those galaxies, we find stars of different sizes, colors, temperatures. The larger stars, strangely enough, end their life in a much shorter amount of time. They usually go out in a bang, and within the supernova explosion, throwing their material within the interstellar medium. That material becoming the sustenance for new stars to form, and if there's enough material, maybe even planetary disks and planetary systems like our own. Now, some students might think that these great cosmic changes are privy only to astronomers that live at the tops of mountaintops using giant observatories, but that's just not true. You and your students too can witness these great cosmic changes, particularly changes and motions within our own solar system. The stars in the evening, if you watch long enough, you will notice that the stars seem to rise in the east, travel across the southern sky in the northern sky in the opposite direction, making circles around the north celestial pole. Then ultimately those stars go down in the west. And this is, of course, an illusion caused by Earth's rotation on its axis. It's called diurnal motion. And then because of Earth's orbit around the sun, we are privy to different parts of the Milky Way galaxy throughout the year, giving us different seasonal constellations. Of course, these stars aren't the only thing that are moving across the sky. The sun, the moon, the planets, these are also traveling across the sky along a line in the sky called the ecliptic. And the ecliptic is essentially the plane of our solar system. And any given night, you might get a chance to see the moon on the ecliptic. You might get a chance to see one or two planets. And if you're lucky, if you're going out at the right time, you might have a chance to see a number of planets all lining up like a parade along the ecliptic. And when this happens, it is called an alignment. Here in this computerized graphic, this is not an actual picture, we see a beautiful alignment from last year. And later in today's program, I will be mentioning a very special planetary alignment. And you'll see why it's very special once we get there. Now, since these planets are orbiting around the sun at different distances, they have different speeds as they orbit. And because of that, sometimes these planets along the ecliptic will meet each other. And when they do meet each other, we have what is called a conjunction. Here's a conjunction that's coming up. This is August 14th, and it says 3 a.m., but you can go on out on August 13th throughout the evening and see this. But at 3 a.m., they will be at their closest. Now, of course, that's just from our point of view. If you were able to see these two from a right angle, they would be extremely distant, about 360 million miles from each other. But from our point of view, they look like they're extremely close. How close? Well, if you hold your arm out at arm's length and stick out your pinky, the width of your pinky, and this doesn't matter if you're an adult or it's one of your students, it works pretty well. The width of your pinky is about 1 degree or 60 arc minutes. These two will be 20 arc minutes from each other, 1/3 of a pinky width. So yes, they will be extraordinarily close. And this is something to get down on your calendar and check out. It's going to be absolutely beautiful. There are some other motions in the sky. For example, when an object with a smaller angular size, apparent angular size, let's put it that way, travels in front of an object with a larger apparent angular size, we have what is called a transit. And if you take a look at this image right here, that little dot there, that is not a sunspot. These are sunspots, but that is actually the planet Mercury. This was during the transit of Mercury, the planet traveling across the face of the sun on May 9th, 2016. And you will get another chance in, 9 years from now to see another transit of Mercury, May 7th, 2033. Another type of motion is called an occultation. And in the lower right, you will see the occultation of the star Aldebaran. This is actually a video, so keep your eye on that tiny star there. The moon is slowly moving, and the part of the moon that's not illuminated just covered up and tarries. So in this case, we have an object that has a larger apparent angular size moving over an object with a smaller apparent angular size. Bye-bye, Aldebaran. There it goes. So once again, that is called a lunar occultation. In this case, it was a lunar occultation of a star. Why am I bringing all this up? Because today's program is about a lunar occultation of a star, isn't it? In this case, the moon is covering up our very own star, the sun. And these particular lunar occultations, of course, have their own name. And in this case, it is a solar eclipse. This is a picture of the solar eclipse that the path of totality went right through Nebraska in 2017. I hope everyone had a chance to see this amazing, amazing thing. It's hard to believe it was 6.5 years ago. Here we can see the so-called diamond ring effect. I took this picture just the moment the moon started to move back off of the sun again. For an eclipse to take place, whether it is a solar eclipse or a lunar eclipse, 3 things must be valid. Number 1, it must be eclipse season. And this is maybe a term you haven't heard before. It's not really bandied about too often. It really is a function of the moon's orbital tilt and the position of the Earth-Moon system around the sun. And we'll talk a little bit more about eclipse season here in just a moment. Number 2, the moon must be in the correct phase. Well, technically, it must be in the correct position around the Earth in relation to the Earth-Moon's position around the sun. But this is also what determines the phases that we see. So ostensibly, it's a little bit easier just to say the moon must be in the correct phase. And then number 3, the viewer must be in the right place at the right time. At any given time, one half of the Earth is illuminated. One half. At any given time, one half of the moon is illuminated. It doesn't matter where the moon is in its orbit around the Earth, one half of it is being illuminated. Really, any planet in our solar system, one half of that planet is being illuminated. And the reason why is because, well, we have just one light source in our solar system, the sun. And this is really easy to show in a classroom. If you have a globe, you can turn out the lights. You need to make it nice and dark in the classroom, and then use a single flashlight or a single bulb on one side, and just one half of that ball or that globe will be illuminated. The phases that we see of the moon, whether it's a new moon or a full moon or the quarter moons when it's at a right angle, or the phases in between, waxing crescent, waxing gibbous, waning crescent, these are caused by the angle in which we view this one half illumination. It's not actually changing, it just looks like it from our point of view. And when you look at a graphic like this, most students will kind of call you out on this. It sure appears as if the moon there on the right is going to block the sunlight and cause a solar eclipse once every month. The moon on the left should be just falling within the shadow of the Earth, and we should have a lunar eclipse once every month. And of course, that's not the case. And it really comes down to the fact that this model is flawed. First off, that moon is a little too big. As you know, it's a quarter of the size of the Earth. But more staggering than that, and this is what really surprises people, the distance of the moon is 30 Earth diameters away. 30 Earth diameters in one direction, 30 Earth diameters in the other direction. And that shows you the 60 Earth diameter of its orbit around us. Then you add in a slight tilt, a 5-degree tilt in the moon's orbital plane. Now you can start to see that everything really does truly need to line up just right for us to have an eclipse. That brings us back to number one. It must be quote unquote eclipse season. You will see that the orbital plane on the right and the left of this graphic carries it above and below the orbital plane of the Earth. You cannot have an eclipse. This would be unfavorable for an eclipse. The shadows just don't meet up. However, the graphic that is further away and closest towards you, you can see that this takes place when the axis of the moon's inclination is in line with the sun. During this time, it is known as eclipse season, and it is favorable for an eclipse. That does not mean that you will have an eclipse. It just means that it can happen. If you look carefully, you'll be able to see that something else needs to take place, doesn't it? The moon must be in the correct position around the Earth. Or I guess you could say it must be in the correct phase. For a solar eclipse to take place, it must be a new moon. For a lunar eclipse to take place, it must be a full moon. If it's not a full moon, you will not have a lunar eclipse. If it is not a new moon, you will not have a solar eclipse. It also must be taking place during eclipse season. Here we have a lunar eclipse, and this takes place when the moon falls within the very large shadow of the Earth. Now you'll notice that the shadow of the Earth has two different parts to it, a lighter penumbra and a darker umbra. And you can represent this in the classroom very easily with a flashlight shining on your hand and then projecting it up on the wall. You can see the darker umbra and the lighter penumbra. It all comes down to where the moon is, whether it's within only the penumbra, whether it's just dipping its toe within the umbra, or whether it falls completely within the umbra will determine whether you have what's called a penumbral, a partial, or a total lunar eclipse. And as a total lunar eclipse takes place, as the moon falls within the umbra portion of Earth's shadow, it looks like it's being eaten away, like a giant lunar cookie being bitten away, disappearing. But instead of completely disappearing, once the moon is within the umbra portion of the Earth's shadow, something amazing happens. Longer wavelengths of light that are being transmitted through, refracted through Earth's atmosphere, re-illuminate the moon again with this reddish orange color. A very romantic way of putting it is that the moon is illuminated by 1,000 sunsets. That's kind of nice. This color also gives it a very interesting name. It is sometimes called a blood moon. Now, as you can see, the moon must be on the far side of the Earth. It must be in a full phase during a lunar eclipse, but for our solar eclipse coming up, it must be right in between the Earth and the sun. Now we have that umbra and that penumbra. This comes down to really number 3, doesn't it? The viewer must be in the right place at the right time. If you are on the Earth and you are outside of the penumbra, no eclipse for you of any kind. If you are within the penumbra, you will experience a partial solar eclipse. The umbra is transmitting a path across the Earth that travels at thousands of miles an hour, called the path of totality. You remember this from our last eclipse. And as you travel within the penumbra towards the path of totality, the percentage of obscuration of the sun gets greater and greater and greater. And once you are inside of the path of totality, then you have the chance to experience a total solar eclipse. If you are outside of it, you will just see a partial. And again, the obscuration percentage depends on how close you are. Now, you'll remember last year we had what's called an annular solar eclipse. This took place when the moon was, well, at apogee. It was a little further away from us than average. And because of that, the angular size was a little large. Or a little too small, rather, to completely cover up the sun. And we got a ring of the sun, a ring of fire. In mathematics, this ring is called an annulus, and therefore this type of eclipse is called an annular solar eclipse. If and only if you are within that path of totality, you will get a chance to see that total solar eclipse. Here are total solar eclipse paths between 2001 and 2025. These paths can range in thickness from just a few miles to hundreds of miles in thickness, all depending on the angle in which that shadow is hitting the Earth. They're usually between 70 miles and 125 miles thick. But luckily for us humans, they are thousands of miles long, giving the opportunity for millions of people on the Earth to enjoy a beautiful total solar eclipse. This year's path, and you'll see 2 paths here. The path on the left was from the annular eclipse last year. The path on the right is to this year's eclipse. It's going diagonally about 2,000 miles from Eagle Pass, Texas, all the way up to Holton, Maine. And the shadow at different times is going to travel between 1,500 and 3,000 miles an hour across the United States. And if you happen to be within that path, right in the middle of that path as it passes by, you will get to experience a total solar eclipse for a maximum of about 4 minutes as it whizzes by. Now, here on the right, I have a list of all the more popular cities. And by the way, if you look at my small image over here, this map, this is the one that I printed up with some NASA graphics and then added some Nebraska-specific information. This is what's available. There is a PDF that I'll mention a little bit later of this, but also I can send you pre-printed out versions of this poster. But on the right here, I have the major and or best placed cities. And in yellow, I have highlighted the 3 that are closest to us. And I actually measured this from Ashland, so right between Omaha and Lincoln, because most of my audience is in that region. And you can see that Poplar Bluff, Missouri, and Carbondale, Illinois, which is where I'll be for the eclipse, is at its closest at about 500 miles if you have a chance to get within the path of totality. Unfortunately, as you probably know, traffic is absolutely horrendous at this time, and those hotel rates are spectacularly high. Super 8s and Motel 6s are in the $700, $800, $900 range. So probably the best location for you to be, if you do have the opportunity to travel within the path of totality, is to maybe find some family and friends somewhere within this path and stay with them and share this wonderful event. And of course, I absolutely encourage you to get within that path of totality if you can, but I absolutely understand that not everybody will be able to do that. If that's the case, just stay here. Enjoy a beautiful partial solar eclipse. In Omaha and Lincoln, we will experience about 80% obscuration. It will begin at about 12:40 or so just right after noon, and it will end about 3:10 with maximum obscuration. So it'd always be good to, if you do have many events, to try to get them around that maximum point. At this time, it's around 1:55, around 2 o'clock or so. You can see the times are very, very similar for both Omaha and Lincoln. But as we move across the state, you can see the amount of obscuration gets less and less and less. If we go over to Scotts Bluff, for example, the obscuration is all the way down to 63%, but still an amazing sight to behold. Because of the time change and because of the shift across the Nebraska here, it's going to start much earlier at 11:33 with maximum obscuration at 12:45, ending around 2 o'clock. How do we safely observe an eclipse? Well, of course, lately, the most popular method is using these total solar eclipse glasses. And if you still have some left over from the last eclipse, wonderful. But you do want to make sure, because of that thin mylar film, that it hasn't been punctured or damaged in any way. If you do need glasses, as I mentioned earlier, for any folks that are new to the program here, if you contact me, I will get you some glasses. Whether you need 25 or whether you need 100 glasses, I will send these to you, because we want all of your students to experience the eclipse and do it safely. The one issue with these solar eclipse glasses, which, by the way, it blocks all the UV, all the infrared, and then it cuts down the intensity of light by about 10,000 times. The only issue with these solar eclipse glasses is using them with young children, because they might fiddle around, they might look above or below the bridge of the nose, they might fall off. So a really nice activity and a fantastic way to make it safer is to create one of these mask modifications for the kids. And as you can see, what we have here is just simply a paper plate. We have traced the rectangle of the glasses. We've cut a nose and mouth piece out, and then we have cut out a rectangle a little bit smaller than the glasses themselves. Then on the edges, we've placed little slits in the paper plate for the arms of the glasses to come through. String is placed on the arms here to tie it onto their heads. And here's a really nice thing. You can see that the kids can design these things using their own artistic license, do something really beautiful. So this makes a great art activity to do before the eclipse. And of course, not only do they put their name, I might suggest putting the date of the eclipse as well. So this makes for a fantastic keepsake for this wonderful event. Before solar eclipse glasses were popular, you probably remember these pinhole camera type apparatus. This is what was used, particularly the shoebox version. And you'll notice the shoebox version there on the right, they did something very clever. Instead of puncturing the hole in the cardboard, they cut a large hole and then placed aluminum foil, taped it on top, and then punctured the aluminum foil. It produces a cleaner hole. The only issue that I have with the pinhole method, if you've ever tried it, is that the image that it projects on the screen is tiny. So what I did is that I created a version using a paper tube. This is a wrapping paper tube where I placed the aluminum foil on one end, a white piece of paper on the other end with a little window. This is placed on the shoulder of the student with the sun behind them, and then they look through the window and you can see a really nice projected image inside. It's just a nice alternative, and again, that tube can be designed upon. But while you're out, regardless of whether it's you're in an area where it's a total or a partial solar eclipse, keep your eyes open for natural pinhole projections. As that sunlight travels between the holes, between the leaves of a tree, it can project thousands and thousands of little partial eclipses on the ground. Astronomers have also used optical projection to project a very high definition image onto a board. But as educators, you can probably see there is immediately an issue with this. If you have a younger person and this apparatus is not being watched, it can be very dangerous. So astronomers have come up with a wonderful solution here. On the left, we have what's called a sun funnel, and I have a link right there to build your own sun funnel, and the link will also be given at the end of this particular program. And the sun funnel contains this projection, creates a backwards projection onto the screen, and then projects the imagery, and you can see sunspots and you can watch the eclipse taking place. On the right is the sun spotter, which is a beautiful folded refracting, it's actually technically a catadioptric. The light is bouncing, going through a lens, bouncing off of a couple mirrors into a safe location. The problem with the sunspotter is really, it's not a problem, but one thing to be noted is that they're a little pricey if you don't already have one in your collection. And now with the advent of electronic telescopes, the C-Star telescope from ZWO is about the same price as the sunspotter, and it comes with a solar filter, and of course it can do so much more. And then last but not least, the best way to observe the eclipse is through a filtered telescope or dedicated solar telescope. Any nighttime telescope, if you have one with your school, can be converted into a solar telescope using the proper size solar filter, as long as it's covering the objective of the telescope. It uses the same mylar film that the glasses do. The difference is that it's larger and covers that objective. On the right is a very pricey hydrogen alpha solar telescope. Many years ago, I kind of Johnny Appleseeded some hydrogen alpha solar telescopes around Nebraska. From a company called Coronado PST. And maybe there's a possibility that one of these PSTs is in your particular location. So this is what we're all talking about, and I need to kind of speed it up here. During a total solar eclipse, you have a chance to see the corona with the unaided eye. This is the only time you get a chance to see it. And then this pink area around it, very near the edge of the moon, this is the chromosphere. This is what you can see in one of those hydrogen alpha solar telescopes, including with the unaided eye, solar prominences. People like to call these solar flares. Solar flares are something different. These are solar prominences there on the edge of the sun. And this is what's really spectacular, a daytime planetary alignment. If you are within the path of totality, as it gets dark, it gets cooler, you hear the animals and the insects start chirping and the stars come out, but it won't just be the stars. Jupiter and Venus will be extraordinarily bright on either side of the sun. You'll be able to see them easily. But not only that, in the southwest, not as bright will be Saturn and Mars. And if you have a pair of binoculars, maybe you might even be able to catch Comet Pons Brooks. So, what an incredible planetary alignment taking place during a solar eclipse. So, just a few things to wrap things up here. Are total solar eclipses rare? Yes and no. It really depends on how you look at it. Believe it or not, total solar eclipses happen twice every 3 years. It sure doesn't seem that way, but remember, it all comes down to where you are on the earth. But for any given location, it is rare. If you put your chair down in your backyard and you say, by gosh, I'm not moving anywhere, the eclipse has to come to me, you'll be waiting on an average about once every 375 years. When was the last total solar eclipse? Well, of course, that was in 2017, 6.5 years ago. And before that, 45 years in 1979. The next total solar eclipse that we will see that will travel across the United States will be in 2045. So 21 years from now. I hope I'll be around to be able to enjoy that next solar eclipse. I certainly plan to be. But the fact that it's 21 years from now really emphasizes the importance to get yourself and your students out to enjoy this partial eclipse or this total eclipse if you're able to get within that path of totality. Technically speaking, by the way, there is a total solar eclipse in 2044 in the United States, but it's only the northern states. A year later in 2045, it will travel across the entire United States. I have put together some fantastic resources for you, maps, classroom activities, videos, including a video of the hour version of the program that you're watching here. You will see there's a QR code there in the lower left. If you use your phone, you'll be able to just click on that particular QR code. I'll give you a few moments to do that, and that will take you to that website with all of these resources and additional resources as well. We'll wait just a moment to give you a chance to do that if you haven't already done it. And we can bring it back up again and make it available afterwards. All right. And my final slide, I just want to thank all of you for spending this lunch hour, this lunch half hour with me here to learn a little bit more about the eclipse. I certainly hope that you were able to find some information here that you will be able to share with your students. But with that, once again, thank you so much, everyone, for joining me. And thank you, Kim, for inviting me.
Thank you so much, Michael. You are just such a wealth of interesting information. I'm going to watch this recording again. You share so much that I'm going to have to do it again to learn all that you had to share. And speaking of solar telescopes, we do have some still located around the state in Chadron, Scottsbluff, Oshkosh, Kearney, O'Neill, Nebraska City, Omaha, and Beatrice. So if you're not sure where those are in your district or after school program, be sure and email and we'll help you track that down, because that would be exciting for the students to be able to use. Michael, thank you. If people need glasses, they'll be in touch. If they want posters, they'll be in touch.
Absolutely. I'll get those to you.
Post the recording and all these resources on our StayConnected site. We truly appreciate you and your time.
Thanks, everyone. Thanks.
Our next StayConnected is March 21st. History Nebraska will be sharing some of their resources on that day at noon. So thanks everybody for being here today. Thanks, Michael.
Michael, listening to you is just so fun. Brings back great memories from that NASA grant that we had. And I just wanted to say some of our programs are on spring break this week, and one in particular, Shadron, Lorna. And she said, oh no, I'm not going to be able to watch, but I'm sure that many of our directors will watch the recording. And it's impossible not to get excited about this after listening to you.
So well, so nice to see you, Jan.
Yeah, good to see you too.
Yeah, go ahead and share that half-hour version. And then if you want something that's slightly less frantic, there's the hour version. I do have additional information in that as well.
I actually have a Zoom with the directors next Tuesday, and if the recording's ready by then, I'm going to really encourage, especially all the ones that participated in that NASA grant. They're going to want to see and hear you again and get excited all over again about solar eclipses. So thank you so much.
It's really exciting, and I know not everyone will get a chance to see totality, but the fact that there's that planetary alignment taking place during an eclipse, that's a once in a lifetime opportunity. Yeah. It's really something else.
I took a screenshot of some of your slides too about like this only happens so rarely, so I want to make sure my grandsons get an opportunity to check it out because it's really, really cool.
And those people that experienced it in 2017, you really can identify with this odd visceral emotional feeling you have when you see this eclipse, and you can really see why people spend a lot of money to travel around the world to get to experience that again.
You know, we our family, we had gone over to a park in Lincoln. It had been cloudy all afternoon or whenever